Hi, in this lesson, we'll be going over some of the behind-the-scenes tasks that your computer is doing when executing your code. Every program that you've written or seen in this course has its own source code. Source code is the code that is written using a high-level programming language like Java, Python, and C++. They are called high-level programming languages because they allow the use of plain English words that humans can understand. The code written in high-level languages is often called high-level code, and using a high-level language often makes it easier to read and write programs. On the other hand, the lowest level code is called machine code. Machine code is the code that the computer actually understands and is usually represented by lots of ones and zeros. When looking at a machine code file, most programmers will not know what the program is meant to do. That is because writing machine code by hand is an exceedingly rare occurrence in today's world of programming. Instead, programmers utilize the power and versatility of high-level programming languages that come with more features and tools to create programs. So if programmers understand source code or high-level code, and computers understand machine code, how do they communicate? Programmers make use of tools like compilers, interpreters, and other hybrid tools like just-in-time compilation in order to create their programs. These tools are all programs themselves that have been built to make the programming experience better for developers. Let's take a closer look at how these tools operate. We'll start with compilers. Let's say you and a friend are working on a project together and they need to run your part of the program on their machine. When working with a compiled language, the compiler will go through your entire program and then create what's called an executable file. The executable file usually contains the machine code that is needed for a computer to execute a program. Once the compiler is finished, you can then send the executable file to your friend so that they can run your program and they never even have to look at your source code. One way to think about how a computer compiles and executes a program is by comparing it to following a recipe that is written in a language that you don't understand. One way you can follow the recipe is to have someone translate the full recipe for you and then give you the translated copy. You can now use that recipe whenever you want, and you can even share the translated version with other people. Whoever you share the translated version with never needs to look at the original recipe themselves. So, what languages are compiled? Some of the ones that you might have heard of already are C, C++, Rust, and Go. All of these languages are converted directly into machine code that the computer can execute. As a result, they tend to be faster and more efficient to execute than non-compiled languages. One of the drawbacks of compiled languages is that they're not easy to share across different types of devices because the machine code that is compiled is usually specific to the computer that it is created on. Let's now take a look at interpreters. When working with an interpreted language, you make use of an interpreter, not a compiler. If you and your friend are using an interpreted language, instead of compiling an executable file and sending that to your friend, you would create a copy of your source code, and then you would send that copy over to your friend. The interpreter on your friend's computer will then read the code line by line and interpret it on the spot. Going back to our recipe example, an interpreter can be thought of as having a person who knows the language that the recipe is written in and is telling you what to do according to the recipe as they read it line by line. This will be quick to get started initially, but then you will always need an interpreter with you when you want to follow the recipe again. Also, anyone you want to share the recipe with will also need to get an interpreter for themselves to help them interpret the recipe. Some of the more popular interpreted languages are PHP, Ruby, Python, and JavaScript. All of these languages look at a copy of the source code and interpret the source code line by line. Interpreted languages are generally slower than compiled languages. This is because the process of translating the code at the same time that the code is running can cause the program to be slower overall. Programmers also make use of just-in-time compilation. Just-in-time compilation takes features from traditional compilers and interpreters in order to execute code. Java makes use of this type of tool by using what is called the Java virtual machine. Let's now take a closer look at how Java builds its programs. Let's say you write all of your Java code inside of a file called hello.java. Before you can execute the code in this file, the computer will first need to create a new file that it can easily understand called hello.class. This file is an executable file that the Java virtual machine can actually execute. The content inside of this file is called bytecode. Bytecode is sort of an intermediate code between the source code and machine code. So when it comes to Java, it is the bytecode that lives inside of the executable file that gets processed by a virtual machine like the Java virtual machine. You've probably realized that you've never actually had to think about an interpreter, a compiler, or even a virtual machine. And that's because tools have been created to automate this whole process for you so that you can just focus on writing your code. The type of tool that is created to automate the process of executing your code are called build systems. Build systems can manage any type of activity that involves translating one form of data, which could be the source code, into another form of data, which can be the machine code. And most modern IDEs or development environments come with these tools already built in. Build systems can help developers automate the process of compiling software written in languages like C, also packaging applications, which refers to the process of collecting and organizing all of the necessary files and resources required to deploy or distribute a software application. And it also helps with testing. Testing refers to the process of evaluating the behavior and performance of a software application to identify any defects, errors, or unexpected behavior. It is also important to note that there are different types of build systems for different types of software projects. Some of the more popular build systems are Ant, Maven, and Gradle. Ant and Maven are both Java-centric and offer a lot of tools for building Java applications. Gradle, on the other hand, offers a highly flexible and extensible build system that supports multiple languages and platforms. The choice between these build systems and many more that exist depends on the project requirements, the preference of the teams, and the level of customization and flexibility that is desired. Again, modern code editors or integrated development environments come installed with these build systems, or they make it really easy to choose a build system that the programmer prefers. All the programmer really needs to do is write the code, hit run, and then the IDE automatically compiles or interprets the program and then executes it. This all happens behind the scenes, so it may not even be noticeable. Now it's time for you to explore.